Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we are revisiting the Zenith ZT-1. Today is the final installment in the whole series on this machine, where with the first 4 parts, I really struggled to get this thing working. After learning how to use my logic analyzer properly, I was able to figure out the design flaw inside of this thing and get that resolved, so this thing is fully operational. But I still haven't been able to test everything because I have a little bit of a to-do list here, and one of the things that was left to be done was test the internal modem. That of course requires analog phones and analog phone lines, all things that I actually have here in the basement now, so I can actually test that stuff. But beyond that, I want to give this thing a bit of a modern upgrade so that anytime in the future I want to use this, I'm not stuck breaking out telephone lines and using this thing at 300 bits per second. And I will add that the upgrade I want to do to this thing actually is applicable to a lot of terminals and things that are built in a similar way to this, so you could actually upgrade them as well. So without further ado, let's get to testing. The first thing on my Zenith ZT-1 list is testing out the built-in modem. To accomplish that, I think I have everything ready on the bench to facilitate that testing process, which includes analog phone lines, because that thing has, well, an analog modem in it. Each of these analog phones on my desk has an analog line connected to it. This is extension 101, and this is 102. 102 is going to be for the ZT-1, and 101 will be for this modem, which I have connected up to a BBS simulator that I've quickly set up. So powering up this ZiModem, you can ignore the fact that it has the carrier detect light on. There's some kind of a problem with this modem now. It doesn't seem to affect its operation, but it always thinks carrier detect is set. Either way, what's good about this modem is it can operate perfectly at 300 bits per second, which is exactly the baud rate that the ZT-1's internal modem runs at, or at least I think it is. If I use the red phone to dial extension 101, you notice the RD light flashes when basically sending the word ring to the attached device. And then on the Zenith ZT-1, I do have it connected to extension 102, which happens to be a phone jack behind the monitor, and then the red phone is plugged into the ZT-1. So even though the ZT-1 is powered off, the phone does work as a pass-through. So originally I was going to hook this ZiModem up that I just showed you to my lab computer, and then just dial in using PuTTY from the ZT-1 and just type messages back and forth. But that's kind of boring, isn't it? So I decided to fire up an LLM and code up a little web-based BBS, which is what you see here. So if I say connect modem to COM port, and I can pick COM3, which happens to be how the ZiModem is connected to my lab computer, it actually resets the modem and then it says it's ready, waiting for a call. So theoretically at this point, if the modem inside the ZT-1 is working properly, then I should just be able to dial up the ZiModem, which happens to be extension 101, and we should be able to interact with this BBS simulation that's running in my web browser. And please know, while I've prepared this little BBS simulation ahead of time, I have not tested the modem in the ZT-1, so I have no idea if it's going to work. So first of all, let's plug it in to power it up. Hopefully it still actually works. Because I mean, I don't know, it's been sitting here for a while. Looks like it's in serial mode, so I hit Control-Shift-F1 and that switches into modem mode. And I just realized something. We're actually running the ROMs that come from the Zenith ZT-11. And I talked about it in the previous repair videos, but that terminal actually has a different crystal oscillator in it, and the CPU or the microcontroller that's in this thing, the 8031, derives its baud rates directly off the crystal oscillator. And since this is running at the stock speed of like 6.5 megahertz, the 300 bits per second going to the internal modem is not going to be correct. So I need to actually convert this back to its original ROMs before I can have any hope of the internal modem actually working at the correct 300 bits per second. So out with the Zenith ZT-11 ROMs, which aren't going to work in this unless I modify the whole oscillator circuit, and in with its original ROMs. Now, a potential issue with this ROM swap I just did is I think the NVRAM settings for the later ROMs is not fully compatible with these ROMs, and there is a battery that is backing up the NVRAM, which is a small IC. I think it's this one right here that I have the dot on. So I may need to take the tape off this battery. This is just a standard rechargeable nickel metal hydride that is keeping the NVRAM alive while this thing was not being used. And I had this thing off for several weeks. And you might have noticed when I had the menu up, it had some phone book entries, and those were put in when I was originally repairing this. So the NVRAM circuit fully operates perfectly in this thing. Okay, so let's see what happens when we power this on now. It didn't work, but I see why. I put 113 in U114, so I have the ROMs in the wrong positions. Whoops. Okay, they have been swapped over, so let's try that again. Much better now. Uh-oh, we have a little bit of an issue. And I don't think there's a way to do a factory default unless I just rewrite those entries. I'm going to hit F4 for erase all. Okay, yes. Hold the save button, push enter. Let's power cycle the computer or the console or terminal or whatever you want to call this thing, just to make sure. Okay, it looks like we're fine. Let's hit F2 and then F1 to add a phone book entry. And I'm going to call this BBS. And the phone number is 101. And for the type, I'm just going to put data, since it's not really any of those. Hold the button down, hit enter. There it is, BBS, data 101. I think it's now time to call this BBS, and let's see what happens. I'm going to press A. It's clicking. The phone's ringing. Oh, well, that was anticlimactic. It hung up, it gave up. It was my bad, even though I initialized this BBS software before. It doesn't really handle the fact that I turned the modem off and on a moment ago. So we're going to reset this, reconnect to the COM port, and now we should be ready for that call. Let's try this again. Okay, I'm going to do it again. Hit A. I mean, we know it dials, so it's talking to the phone system. That's something. A 0 and a 1. There we go. There's the phone call. Oh. That's the speaker out of the ZiModem. It freaking works. It freaking works. Check that out. So that's us actually dialed up to a BBS. This modem works, and we're running at 300 bits per second or 300 baud. Let's check the weather right now. And yep, you can see how slow 300 baud is. That is the speed of this thing. I don't know why it says plus 87 B0F. I think that weather is not even current. It's not actually 87 degrees Fahrenheit right now. That must have been whatever temperature it was at the moment when I was actually coming up with this little program. Let's try quote of the day. So yeah, we're like accessing information superhighway, so to speak. You can tell whether a man is clever by his answers. You can tell whether a man is wise by his questions. Very nice. Okay, let's check a random joke. I think these jokes are actually pulled off of an API, like from the internet itself. Why couldn't the lifeguard save the hippie? He was too far out, man. That's like a terrible, terrible dad joke. You can roll a die, 4, so it's just like rolling a 6-sided dice, I think, or die. Current time or date. Look how slowly the modem redraws. I mean, this is how fast it was back then. August 25th, 11:09 and 4 seconds PM, and that is exactly the right time and exactly the right date, so it kind of gives away when I'm actually recording this video. And the last item on my fake BBS is PDX arrivals, and this is the local airport. Now, the funny thing is, when I asked it to add this, I didn't realize that it was just like 5 fake flights. In fact, every time we'll load that list, it'll be totally different. And unfortunately, this is not accurate information. I was hoping it would like pull from an API from the actual arrival information, but it's totally, totally not. But as you can see, these are some things that someone might have done with the Zenith ZT-1 back in the day when it was new, checking on flights, looking at quotes of the day, maybe checking the weather, stuff like that. Like, how fun is that, really, right? It brings back a lot of memories. The first modem I ever used was 300 baud, and this exactly is the speed that we did everything, and I was just used to this. I mean, you access stuff very, very slowly, and you really couldn't download software this way, or you know, you could little basic programs and stuff. I was doing this type of thing on my original Apple II Plus. We had a little modem, it was just a little small box, serial port in the back, telephone jacks for the local phone, plus a phone line. What you would do is you'd pick up your phone, you'd dial the number of the BBS. When you heard the carrier, you would then flip the little switch to the originate position and hang up the phone, and you'd be connected. And to disconnect, all you had to do is flip that switch from the originate back to the middle position, which was like, on hook. And then the other position for the switch was answer. You'd arrange for someone to call you from another modem and then wait for the phone to ring and then just flip it to answer. And the modem box would then connect the phone line and produce the answer tone. And the other modem would initiate the connection and you'd be all connected. Okay, so I don't actually know how to hang up the phone because I originated the call from the ZT-1. I guess if I just do a reset, which I think is that hung up the phone. Now there are some options on the bottom of the screen here to connect in originate mode or in answer mode, and that's just like my old manual modem I was talking about, flipping that switch back and forth, so you can actually do that either direction. I see an option there for hang up as well. So yeah, there's a key combo that will bring this menu up even when you're in the online mode, which I couldn't figure out what to do. Normally I just push this help key to bring this up. But yeah, when you're online, I think that key must be sent to the remote end as a key combo or something like that. So yeah, there'll be some other hidden combo to bring it up. And I don't initially see that on here. Break, quit, help, escape, and reset. And what I was going to do is manually dial the modem and then use the command switch to originate mode. So I'm going to dial 101 and it should answer. There it goes. So when I push that button there, hang up, and we're connected. So that's another way for you to gain access. And this might have been important if, say, you were dialing through a system that required you to enter a phone card, like a long distance access card. So you would dial an access number, like an 800 number, toll free. Then you might dial your calling card number. Then you might dial your destination number, which would be like a BBS or something like this. And then you would hear the carrier and then have to initiate the originate mode like I just did there. And we'll just quickly check our flight information because, that's probably what we're going to be doing with this thing, making airline reservations and stuff like that. And we were looking for Delta 290 from Denver, and yes, it landed on time, so I better rush off to the airport. Okay, well, this was the final thing to test on the ZT-1, really from its stock functionality, and we know 100% now that this thing is 100% fully operational. So after changing out that one logic IC, that fixed our video problem with the missing line of text, and the ZT-1, well, the rest of the ZT-1, it just freaking works. Awesome. Now this brings me to the second thing on my to-do list. I wanted to know the whole time, how well does this thing actually work on DC volts? Now with this large power supply that comes with it, it's kind of bespoke and proprietary, and I had to fix it, obviously. That's why there's tape on here, if you remember from one of the early parts. Well, one of the rails in here is just AC volts that gets converted into DC, and then that runs the whole main part of the CPU and all of that stuff. But then the other part of this is another AC waveform that has a center tap. So it's a lot like household power in the United States, where you have 120 volts from neutral or the center tap to one of the phases, and then you have another phase with 120 volts. And if you go from phase to phase, you get 240 volts. Well, it's kind of similar with this, except of course, we're talking about very low voltages. But I think it ends up being about 30 volts AC with a center tap. So you can get 15 volts out of it or 30. Well, it appears like at the schematics that second AC rail is used specifically for the modem. And I guess my question is if you have one of these ZT-1s or a ZT-11 or a ZT-10 and you don't have this proprietary bespoke power supply, can you just use this thing feeding DC into it? Well, let's give that a try and see what exactly doesn't work. I totally presume that the modem is not going to work. Usually most modems, including the Zoom modem I'm testing with here, require an AC input because it uses that AC waveform to create positive, negative voltage rails, and that just helps simplify the design of the modem. So my idea is let's just unplug the power supply and let's just feed DC volts directly into the capacitor, which if I recall is around 12 volts. And then there are two voltage regulators, 7805s, that will regulate that voltage down to 5 volts to run all the logic circuits. That's going to leave the modem pretty much unpowered, which I'm assuming it means it will just kind of be dead. But if you're not going to use the modem in your ZT-1, you're going to use it for other purposes, then this might be an actual good idea and a way to use your terminal even if you're missing this funky power supply. So I have the bench power supply set for 9 volts, which is actually going to be totally fine. You don't need to feed 12 volts into 7805s. You can actually feed 7 volts into them and be totally fine. But I'll start with 9 volts, 1 amp, and let's just see what happens when we power this up. Okay. It's pulling about 800 milliamps, and we heard a beep, so I assume this thing is up and running. And yes, with the 9 volts going into it, we look totally fine. Let's go into the menu and try to use the modem. So everything is ready to go. The ZiModem is ready to accept a call. I'm going to hit A and assume we're just going to have nothing out of the modem. Wow, it's actually dialing. So it was able to dial. So what happened there is it seems that the modem just sort of gave up, and see it says offline, and the ZiModem is just trying to give a carrier to the busy signal coming from the phone system. So it's curious, it was able to dial, but it didn't seem to be able to establish a connection. Why don't we try to do it manually like we did before? So I'm going to dial 101. Hopefully it's going to answer, and we'll try to go into originate mode. Okay, so even though it thinks it's online, clearly the modem is not fully operational in the Zenith, and the ZiModem is just sitting here giving a carrier to nothing. So I'm actually pretty surprised. The modem's working a lot better than I thought it would, but my assumption is there are op amps on here that are used for actually having the modem communication, those digital signals over the analog phone lines, and those are not working. So I think this modem has essentially become deaf. So even though it's able to pick up the phone and dial, it's not able to hear anything. Therefore, even when I put it into originate mode, it never produced any of the tones needed for the far end to actually establish the connection. I'm really not surprised that this is the case, but I just wanted to show for certain that if you're going to use your ZT-1/11/10 and you're not going to use the modem, you can just get away with feeding it DC volts directly into the capacitor. So what I'm probably going to do is drill a hole in the case, add a 2.1mm barrel jack, just a DC standard barrel jack, center positive, and allow me to feed 9 volts through a diode directly into the capacitor. The reason why I want to use a diode is if I ever want to plug the original power supply back in, I don't want to backfeed that power out through that jack. But either way, it would simplify using this thing and not having to worry about this, because you could run it off a little USB power bank with power delivery, or off any conventional 9 volt or even 12 volt power supply would probably be totally fine. Now you're probably asking, why exactly would you want to use this thing without a modem? Well, I mean, the reality is, who's going to have phone lines around like I do here to even simulate a whole modem connection? Not a lot of people. And if you have one of these, well, I alluded to this in the previous repair videos, that this thing actually supports a serial port mode. Even though it's kind of undocumented and hidden, it's actually there. Let's go to the schematics and check out a little bit closer how this serial port stuff actually works. Now, if we head over to my GitHub repo, which I've uploaded all of the schematics and service manual for the ZT-1, we'll notice, taking a look at the power connector for the external power supply, that there are 2 signals on here, brick RXD and brick TXD. Now, the labels that are on here were created by Dan, who created these schematics by hand. But you might be wondering, like, why are there RXD, TXD lines on the power connector? Like, what's that all about? Well, it turns out that when Zenith or Heath designed this thing, they actually had the idea that they would have capability of using external serial devices with it. And to make that possible, they actually installed a couple multiplexers, 74LS153s, to allow you to route the serial signals that come from the CPU. So the CPU is what's generating and receiving serial on these devices. The 8031 has that built in. Well, using these select lines, it's able to actually selectively route these signals either to the modem, to this external serial port on the power connector, or I think even both. Well, this goes a long way in explaining why, when we took a look at the photos that my friend Sark took of his ZT-11, his had a little add-on serial port that exposed a 25-pin RS-232 port through the back of the case. And when you look at the design of this board, it's pretty obvious what's going on. The MC1488 and 89, that pair, is what's made up to convert TTL serial signals, which is what this thing is using, the output and the input, into the 8031, and it converts them to RS-232 levels. Now, normally when you have these types of chips, you do require a negative voltage rail. And when we look at this overall picture of this unit, this is that serial board, which has a bunch of tape on it for some reason, and that was how it was out of the box. Well, it picks up its power as DC power directly off the capacitor, so it's about 12 volts. Well, how is it generating a negative voltage rail required for RS-232 if it's just picking up DC? Well, it's using a relatively simple circuit where it uses a 555 to create an oscillator and some inductors, and that allows it to create the negative voltage rails that are going to be required for RS-232. So that pretty much explains the design of that little board, but what was really curious to me is where this board connected to the computer. Initially, you can see the 4 wires, 2 of them are for power, and then 2 of them seem to go to these 2 connections, and that one, you can see this trace goes up to the power connector. And when I first saw that, I was really confused. Part of me thought that maybe it was picking up one of the waveforms, the AC waveforms from the power supply, and it was using that somehow to create those negative voltage trails. But that is absolutely not the case. Turns out that this little via and that wire there is either the RX or TX line that just goes to the power connector, and that just happens to be the way that they picked it up. How funny is that? Now, what's really interesting is when we go into the menu on the ZT-1, there's really nothing in here when it comes to using external serial devices. We can push F3 for setup, and these are all the setup options. There's nothing about baud rate. There is nothing about external or internal. There's just none of that. So on first blush, you would never even realize this has a capability of supporting external serial devices. But clearly the hardware, even on this first revision ZT-1, is absolutely there. And looking through the manual that came with this thing, it also does not mention anything about how to use the external serial port. Presumably, the manual for the ZT-11 that my friend Sark has would have that instructions. But even on the little personal quick reference card, this also mentions absolutely nothing about baud rate, external, internal, anything like that. Just has something about handshaking and full duplex or half duplex. Well, luckily, thanks to one of my great viewers, we were able to get the service manual, and this does have a little bit more information about how to switch the baud rate. And look, in fact, it says right there, supports up to 1200 baud. Although I just noticed this is pretty funny. Video interface, RCA plug phono connector to any RS-232 compatible monochrome monitor. What is it talking about, an RS-232 compatible monitor? That means absolutely nothing. That's like gibberish. The PDF of the service manual, page 22, does talk about the mode of operation, and I alluded to this stuff in a previous repair video section. But this talks about the different modes that this thing can run in, where mode 0, the default power-up mode, is the modem mode, what we've already tested by dialing into my fake BBS. But mode 1 is mentioned as connects the TTL serial local computer port to the terminal and vice versa. The modem is not connected to the terminal in this mode. So that's that multiplexer where it's disconnecting the modem and just routing directly out of those 2 pins on the power plug. And it talks about how to switch the different modes, mode 0, mode 1, which is the serial mode we're looking at, and it even tells you how to switch the baud rates. You have to use an escape sequence. What I find really amusing about this page in the service manual is it doesn't even mention the fact that those serial lines are available on the actual power plug of all places. Now back on the GitHub repo, we also have the ROM disassembly that was done by Dan. And Dan outlined right here that escape R and one of these letters sets the various baud rates. Now it lists A, B, C, D, E, H, J, and Z. J requires the ability to use baud rate doubling, double rate bauds. I'm not exactly sure what that means exactly, but the funny thing is in the service manual it does mention A, B, C, D, E, H, but it leaves out J and Z. J and Z do seem to have entries in the table, so they likely result in some kind of baud rate. Maybe they're just non-standard, and that's why we're going to need to use the oscilloscope to figure out exactly what the baud rate is. Now, when it comes to actually setting the baud rate on the 8031 MCU, like I mentioned, it's totally reliant on some calculations done and the external clock speed going into it. So 6.5 megahertz in this case, and that particular clock speed with some dividers can result in correct baud rates that match pretty close at least for, well, the baud rates that we saw listed in the service manual. But it seems like if you want to go any higher than that, you need a faster clock speed. And that's why if we take a look at the backside of the main motherboard on the ZT-11, well, they added a little board with a 7.3 something or other megahertz oscillator that feeds into the CPU directly without affecting the clock speed on the rest of the board. And we figured out in those repair videos that you can run the CPU at an asynchronous clock speed compared to the rest of the system, and it works totally fine. Well, it turns out this 7.37 whatever megahertz crystal is the appropriate one to give you baud rates up to 9600 bits per second using the dividers inside the 8031. So almost certainly this particular crystal oscillator, along with the ROMs for the ZT-11, which we had in here earlier, would result in baud rates up to 9600 bits per second. But since this ZT-11 is running the stock ROMs and we're running the stock crystal oscillator, that means we're going to be stuck to, well, probably 2400 bits per second, unless one of those doubled baud rate ones works at like, hey, 4800 bits per second. So we have a couple possibilities on what to do with this newfound serial port to make this thing a little bit more useful than the built-in 300 baud modem. One thing I could do is I could try to cut a hole in the back and add a serial port like a DE9 connector, or I suppose I could try to make a little adapter where the power is split with a little Y cable and we have a little serial breakout cable along with the power that feeds through that. But I've actually been thinking about a better solution, and it is this right here. What we have is an ESP8266 board. It's just a really small one I had sitting around. I think these would cost just a few dollars. It's got some components on the back specifically for programming via USB. And I flashed this with the ZiModem firmware from Baud Zimmerman. ZiModem is a modem emulator firmware for the ESP8266 and ESP32 that allow you over a TTL serial link to communicate with what looks like a normal modem. But as is typical with all the Wi-Fi modems that are floating around, they're all pretty much running that same firmware. You can just telnet or dial up to any telnet BBSs with a device like this. And since this thing is so small and just runs off 5 volts, why don't we just install this internal to the ZT-1, basically giving this thing Wi-Fi connectivity for connecting to BBSs and stuff without even having to drill or modify the case at all. And because the multiplexer and the 8031, the serial connection is just 5 volt TTL, and the 8266 is 5 volt TTL compatible, we can just connect this thing up directly to the CPU and get this thing online. Now I happen to have some other serial modems, and here is one of them. And all this is inside is just an 8266, much like this one here. It's a little bit bigger of a form factor, and I have it just hooked up to this little board, which happens to be a DE9, so RS-232 to TTL converter board. I don't know exactly what this SIPX chip is in here, but I'm assuming it's like a MAX 232, which is exactly that. It's TTL to RS-232 converter. This thing has all the voltage converter stuff built into it, so you can just feed it 5 volts, and it outputs the negative voltage rails for RS-232 serial automatically. Now I could easily just take a board exactly like this and install that right into the ZT-1 and just wire it up to those 2 same connections that the little serial board that Sark has in the ZT-11, and this thing will just work exactly like the ZT-11. And you can just buy these little converter boards very inexpensively from places like eBay, AliExpress, and stuff like that. They're just a couple dollars each. So that's a good route. If you have one of these and you want to go online with it, but you don't want to hook up an internal modem like I'm going to do with this, I would recommend just finding one of these boards and just sticking it inside. But we're going to go with the Wi-Fi modem approach, which I think would be more slick and more cool. Now, when it comes to flashing the ZiModem firmware onto ESP8266s and ESP32s, there's plenty of videos online about that, and I'll link to the GitHub repo, so I won't get into that, but this one's already been flashed, and I tested that it's working, using my modern computer, so we should be all good to go at, well, getting the ZT-11 or ZT-1 online. Now, amusingly, one of the connection points for the serial board that was on Sark's machine was that via right there. Well, it looks like it's been damaged by the leaking battery, so I probably won't be using that. So I may need to take this board out to try to figure out a better connection point to that particular signal, which I think is going to this IC. So it's probably going to require me taking this board out and putting it on the underside. And you know what? This is probably a good excuse for me to potentially fix this battery situation and maybe install a CR2032 battery holder as opposed to these silly wires and a regular rechargeable battery. Okay, battery holder is installed with the diode so it doesn't charge the battery, and I've installed the wiring for the serial port or the modem. I did end up putting it on the same 2 spots because this via, the one that looked a little bit damaged, was actually okay once I cleared the crap off of it. This via here is the TXD line. It goes to 145, which is this chip on pin 13 and pin 5. Pin 7 is the RXD line, the receive line going into the CPU, well, through the multiplexers, and is picked up off that via. These were the exact same connections as used on the ZT-11. If those are more damaged on your board, you have to take the main PCB out, and then you can connect up to the bottom of the chip or the bottom of the 9-pin connector, or there's a bunch of different spots you can connect to. All right, first things first, I haven't tested to see if the battery is working, so let's power this thing on. Let's make sure everything's plugged in. Yes, it is. When we push help, it's going to make us do a factory default, so we have to push the save button, hit enter. I'm just going to add a phone book entry just as a test. We'll do it as a data connection. Okay, yes. Hold down the save button, which incidentally does hook up the right enable line to the SRAM chip. There it is. Let's power cycle the entire computer. I'm not quite sure how long you have to leave this off just to ensure that the contents are preserved. Probably a little while, because usually these very low power SRAMs, like what's used on here, are able to retain their settings for a while, even without any power. Let's see if that did the trick. There we go, it's still there. So I'm gonna make the assumption that this fully works. I did put a little plastic card underneath it because the underside of these battery holders does have some exposed metal, so I just didn't want it to touch any of the other stuff. And now this is confirmed working. I'm going to use a little bit of hot glue on the underside of the battery holder just to glue it to that plastic card so it doesn't move around. For hooking up the Wi-Fi modem, 5 volts ground, RX and TX. I picked up the 5 volts just off that little bypass cap for that particular IC, it's just regular 5 volts. And the blue wire is what's hooked up to the RXD line, that's this one right here. So I'm going to connect that to the TXD line on the modem. And then the purple wire is TXD coming out of the CPU, and that's going to go to the RX on the little microcontroller. I might need to reverse those, but let's just start there. Just for testing, I'm going to stick the modem right there on that little bit of blue tack just so it doesn't flop around. Now, when I pre-configured this, I think I set the baud rate to be 1200 bits per second, but actually I might have set it for 9600. And in that case, it's not going to work. So I may need to reconnect this to my lab computer just to resave the baud rate into the firmware. But let's power this on and see what happens. Hopefully we don't let the magic smoke out of the modem. Okay, a little light flashed on it, so that's a good thing. Okay, so according to the service manual, we got to switch to mode number 1. Mode 0 is the built-in modem mode. Mode 1 is Control Shift F2. And now next to offline up there, notice it has a little 1 next to it. According to this little reference card, Control Shift Space is the switch between offline and online mode. Control Shift Space. Now it says we're online. AT. Okay, we're not getting anything at all. Now we're making a lot of assumptions that, well, the signals are working here, this is hooked up correctly. So what we need to do is probe around on the inputs and outputs on here with the oscilloscope and see what we see. Okay, so when I type, oh yeah, okay, cool, we see stuff there. And unfortunately, that's going into the TXD line on here. So I think I have these cables reversed. So I'm just gonna power this off and swap these around. Sometimes it's hard to know with these little boards how they're labeled on here. So we'll switch those around. I'm going to switch this back to online. Actually, what I want to do first, let's go into help. And I'm going to change one of these settings, like this one here. And what I want to do is I want to save these changes. F4, hold save, push enter. What I want to see is if I power cycle this computer, will it stay in mode 1? So we'll just do reset. No, it went back to the modem. Very curious. So I know that the ZT-11 firmware, which we can't use on this unless I modify the clock, it does save if you're in serial mode. So with this thing, anytime you want to use this, you're going to have to manually switch over to be serial mode. Anyway, so we're switched in serial mode. We're going to set it to online, AT. Well, we saw an A, and then it just sort of stopped. But I think the baud rate is currently wrong. Oh, wait. All of a sudden, it's freaking just working. What? When we hit enter, we get 2 enters, and I think that's because we got to switch back to offline mode, and I got to turn off that line feed thing I just set in the settings. Auto line feed on carriage return, so V. Okay, so now we're going to save the settings back into it. Go back online. Wow, it just freaking works. I knew there was a help mode here, and there it is. Not connected. I have the access point that I use for this turned off right now. I'll just power cycle the computer. Okay, so yep, I went online. It's just set for 300 bits per second, and the modem is talking to this thing immediately. It says it can't connect, but that's fine. Yeah, it just works. I still can't believe it that it's just working. All right, looks like it's actually connected because I typed AT and help, and now it's actually listing out a file, and it pretty much downloads this directly off the internet. You can see how slowly this is going. And I hit Control C, and that doesn't seem to do anything at all. I think at this slow baud rate, while the Wi-Fi modem firmware works, I think a lot of it just gets buffered, so it just keeps sending to the computer kind of indefinitely. And I'm going to spend a moment to glue this stuff down with some hot glue, which my hot glue gun is warmed up. I can smell it. So I decided to stick the ESP8266 right here on the power connector instead of on top of the capacitor. And the reason why, there's just not a lot of clearance. The case kind of slopes down, touches the back edge here, and it just hits the top of the case. But with the keyboard in place, this is exposed. And when I place this lid over it, there's just plastic right here. So at least the Wi-Fi signal can get through the top part of the case for some amount of reception. Ideally, if I really wanted it to work better, I would have extended these wires and I would have just hot glued it onto the backside of the case right here. That way the antenna right here would have the best ability to, reach access points. But I think that's going to be just fine the way it is right there. I also glued down the battery holder so it's not just flopping around anymore. I mean, it was held up by the metal leads that were going to it, but now it's nice and sturdy. Okay, the lid is on. It's exactly the position it would be if this thing were screwed together. Let's see how it all works now with everything buttoned up. Power this on, quickly switch to mode 2, and we switch to online mode, and we should get an update from the Wi-Fi modem just in a moment. It boots up, there it goes. Connected to bench, there we go. We're actually connected to the internet right now. Oh, so cool, so freaking cool. Now, one thing we can try doing is setting the baud rate on the Wi-Fi modem. I'm going to set it to 2400 bits per second. Of course, we're not getting a response, an okay response, because it has changed its baud rate. And now we try to change the baud rate on here with escape, lowercase r, capital H. That didn't seem to work. To be honest, I'm not really convinced that the baud rate is even changing. And I think that might be happening because we're in online mode. So let's switch out of online mode. So we're in offline mode. That's Control Shift Space. Now we'll do the escape sequence, escape R, capital H. Okay, so we're able to type, but we're not in online mode. We'll switch back to online mode. Oh, there we go. That works. So that's the trick. You can change the baud rate only when you're in offline mode. So now if we do at help, this should go a lot faster. There it goes. So here's one of the issues with this firmware is it doesn't really have the ability to auto detect the baud rate, because if we go back to just regular offline mode, in fact, let's just reset the entire terminal. It's not going to reboot the modem, but it resets the terminal. Switch to online mode, and we're going to be at 300 baud right now. And when I type commands, nothing happens at all. So we have to go to offline mode, escape R, H, go back to online mode. I think we should be in 2400 bits per second now. Yeah, now it's fine. So with Hayes compatible modems, you could change your baud rate and just type AT, and that was enough to get it to retrain to the new baud rate. But this firmware doesn't seem to do that. So you got to use that baud rate command ATB to set the baud rate and then save it to a profile. But if I change it in the firmware of the modem, that when we power cycle the entire system, this computer will go back to being 300 bits per second. And you have to go through that manual process first to change the baud rate on the terminal, because you have to do it every time you power it up, before you can even talk to the modem. So you might actually think the modem is not working because AT commands don't really do anything until you fix the baud rate. So I'm thinking it might be better to leave this modem set for 300 bits per second just so it works as soon as you power up the computer every time, and then leave some notes with an instruction sheet that tell you the commands you have to enter on the terminal and the modem to switch to 2400 bits per second. Now, one thing I'm curious about, in the firmware that Dan disassembled, it talked about a bit doubled bit rate. Now, I'm wondering if that is like 4800 bits per second. Does this modem even accept that as a baud rate? Yeah, I think it might. So baud rate H was 2400 bits per second, and baud rate J theoretically was double that. So let's give that a try. So we'll switch to offline mode, escape R, J, back to online mode. No, I don't know what baud rate this is actually running at. Now, when it comes to the ZiModem firmware, and I just reset the whole computer, so we're back to 300 bits per second. I don't know if it supports arbitrary baud rates. Like, could I type ATB 4700? Wow, it actually takes that. So maybe I need to really figure out what the baud rate is when we use that J baud rate using the oscilloscope. And then maybe we can just set the baud rate to exactly that, or, in my notes, I guess that's exactly that. So we'll have a working faster baud rate. And there was another baud rate available to us as well. It was escape R and the letter Z, capital Z, which if we go online again, I don't even know what baud rate it's sending right now. I figure it's probably sending as fast as possible. So we really need to use the oscilloscope to just figure out the baud rate. And then maybe I can just set the modem to that arbitrary baud rate and we can have much faster speeds. Let me give that a quick test. Okay, so we're going to do a single shot here, and we'll use the letter A, and this will allow us to calculate the bits per second. We're at the default 300 bits per second. So we set the cursors up to a 1-bit size, so letter A is a perfect example, the first bit, and 300 hertz. So that tells us 300 bits per second. Okay, so I'm going to take it offline, escape R, capital J, bring it back online, and it still looks like it's 300 baud. That didn't change anything. Take it offline, escape R, H, bring it Bring it back online. Let's see, we should be at 2400 baud now. Oh yeah, so much faster. Okay, so now we're going to do single shot and move the cursors, and there you go, 2.4 kilohertz, 2400 bits per second. So you can see right here, it was HJZ. J requires the ability to use double baud rate. Well, I don't think that works, because if we go offline and we go escape R capital J back online, and we type the A command, we're just still at the exact same baud rate we were at before. So it looks like that J baud rate from the firmware, it doesn't actually work. Let's try Z. Escape R capital Z, back online, and oh, that is a faster baud rate. Okay, so Z works. So I'm just going to zoom in here, go to single shot mode. My assumption is this is going to be some very oddball baud rate, because with this clock, it's not really going to produce a proper high speed one. Yeah, the baud rate appears to be 16,800 kilobits per second. Very odd, but you know what? That might work with the ZiModem firmware, and that will obviously be super fast. So let's power cycle this thing. We'll go to online mode, wait for the modem to boot up. I forgot to switch to mode 1 there. So now we should be booted up. Yes, we are. ATB 16804. Odd baud rate, but let's see if it takes it. It seems to have taken it. So we have to go offline. Then we go escape R capital Z, back online again. AT. That worked. That weird baud rate is working. So we can do a help screen now. Look at that. Super fast. So I don't think any actual modem, like a real modem we would connect through a serial port, would work at this baud rate. But the ZiModem firmware on the ESP8266 totally does. So I wrote that in the command ATB 16804. That's so hilarious. Okay, so I can connect up to my Alpine Linux Docker image, or it should be 11. There it is. Oh, a little blue LED turns on to show that this is actually connected up. There we are, we're actually connected. Okay, so terminal emulation wise, as far as I'm aware, this is VT52-ish. But I'm not quite sure that's accurate, because we have a control code that's sitting right there. Oh, although terminal type is VT100. I need to fix that. Okay, so I just changed the terminal type to VT52. Let's see what happens when we run top. It does not work properly. Definitely works properly with VT100, but no, it's not working here. So that makes me assume that VI is not going to work either. No, that's definitely not going to work. Oh dear. So let's exit out of that. Weird. I'm going to have to do a little bit of investigation to figure out exactly the correct way to set Linux to VT52. My assumption is it's possible, and I think this thing is VT52 enough that theoretically we should be able to get some of the control codes for like VI working and top and stuff like that. But before I go fool around, let's just do a quick ls-lr to dump a whole bunch of text at this thing. Can it keep up? It's freaking keeping up with 16.8 K baud or K bits per second. That frankly is very surprising, although maybe it's freaking out now. Is it dropping stuff? Still be going. I'm not sure why it's making those beepy noises though. Now this does support X on, X off, and I don't know if I have the ZiModem firmware set up for X on, X off. It can be set up that way, but it doesn't always work super great. We have to remember the connection from this over to the server here is over Telnet, and it's running at like Wi-Fi speeds. So far faster than the 16.8 K bits per second that is talking to the terminal. So I think the far end is just like sending text super fast, and it's kind of being buffered here. And I've just found the flow control stuff never really works correctly. Like I hit Control C, seeing it doesn't really stop anything. And that, unfortunately, is one of the issues with the modem emulator. It just, well, these are these little flow control issues that I've seemed to always run into, no matter what baud rate combination I'm using. I always run into this particular issue. Okay, I did a little bit of reading. It looks like one of the things I didn't have set on the firmware here is ATF1, which enables X on, X off flow control for the ZiModem firmware, but that's turned on now. So let's switch to the faster baud rate. Escape R capital Z, go back online. There we go, we're working. And I modified this login using a different session, and see it says terminal type is VT52. Pretty sure that doesn't really make a difference, and nothing is really going to work properly. Yeah, I don't think that makes any difference. I guess the question is can I push the up arrow? No, even the arrows don't really work as expected. So this kind of makes this thing a little bit less useful. Oddly enough, if you look at PS1, I don't see any kind of like weird escape codes in there. So why is there a 6N at the end of my prompt here? I figure that is some kind of VT escape code that's just not supported on this terminal. But based on this card here, this thing does support like reverse video, blinking video, erasing lines, positioning the cursor around. But VT52 is old, and I just think Linux, at least this modern version here, doesn't really support it. I don't see escape and lowercase n as one of the supported commands. Well, it's a bit of a bummer. I was hoping to be able to run some things in Linux that would use some VT control codes to, you know, show inverted text and format and clear the screen and things like that. Let's try calling into an actual BBS. See if this is actually working. Ah, yes, it is. Okay, what's really cool is, let's do visitor. I think this might be able to let us set the terminal type. Yes, 80 by 25 or 24. Terminal type, VT52. Let's see. You know what, it might not even matter. Running on an iWill KT133A AMD Duron. Looks like Mufasa has been connecting with Telnet. Read new messages, read all messages. Let's just read all messages. Hopefully there's nothing inappropriate here. Now, I'm not really logged in, I'm just as a visitor, so maybe there's more functionality here we don't have the ability to do. Now it's funny because we're running at 16.8 kilobits per second right now, and yet you saw the text update speed is more like 2400 bits per second. So I think we can pick a message to display, 305. Connection, ASCII Telnet, 1200 bits per second. Hi, how are you? And someone replied to that. I assume N is for next message, maybe? Yes, it is. Well, hello to you, Vaxi. I'm just fine, thanks for asking. I hope you're doing well. I hope you come back here soon and add more to the conversation, Bob. Okay, well, you know, this BBS is very much designed for dumb terminals, so it doesn't really seem to use any terminal type stuff, and that's perfectly fine for this old ZT-1 terminal. Okay, I just logged off. Thanks for visiting. Hope you see you soon. Level 29. Okay, I just tried another BBS that people said supports VT100. I think this is an Atari ST type BBS. So we're gonna go 80 column mode. Oh yes, here we go. Mono only and color VT52. Let's try color and just see what that does. Okay, I guess it's not quite working. Let's see if I can hang up properly. Plus, plus, plus. Yes, good, that works. ATH. Let's try calling back, but this time we are gonna use VT52 mono. See if that works a little bit better. 80 column mode, 1. 2, mono only. Oh, hey, that's working at least. Boldly going where no Atari ST BBS has gone before. New, if you're a new user. 80 column display. Can your terminal display 80 columns? Yes, it can. Well, that didn't really display correctly, but at least it's clearing the screen properly. Okay, yeah, it's kind of corrupting a little bit. My assumption is this terminal's probably not totally VT52 compatible, and this BBS is probably tailored to Atari ST terminal emulators, which probably do a better job. Do you want a permanent password? I don't know. No? What's your real name? Okay, well, we're not going to do this right now. Well, and with that, that is it for the Zenith ZT-1 series. Getting this thing up and working was way harder than I ever thought. In fact, the video you just watched, I thought was going to be probably in part 1 of this whole series, or maybe part 2. I never would have suspected this thing would have been so difficult to get working. Now that was a big learning experience for me, and I learned a lot, especially about using my logic analyzer. But I think people are pretty much sick of watching me fiddle with this thing at this point. So I'm glad to have it done and dusted and all back together. I feel like I've done this thing proud by upgrading it beyond what it was ever meant to do, meaning adding a Wi-Fi modem directly into here and showing you how to do the same if you ever want to do it. And the fact that this thing can run at 16.8 kilobits per second actually makes using that pretty nice. If you're just going to use this for, well, some dumb terminal activities, awesome. It's super fast and it doesn't seem to drop characters. And even though it's only X on, X off, seems to work really well, even at that high speed. It's unfortunate that I couldn't show off any of the terminal capabilities of this thing. I did play around with that stuff offline based on what was in the little info card here. It can display reverse text. It does have blinking and underline and some other parameters and stuff like that. They all work fine, but it doesn't seem like any of the BBSs or Linux I could connect to support any of those modes, which is unfortunate. If this thing were VT100, it'd be a whole lot more usable because this keyboard, which is an Alps SKCC board, feels excellent to type on. The layout isn't too terrible. It's not super conventional, but still not too bad. And if this thing were VT100 compatible, then you could use VI and all the modern stuff on Linux to totally work from this thing. But as it sits right now, it's not really super capable. If you can think of any awesome things I can connect to that really can exercise the kind of VT52-ish compatibility of this thing, then comment that down below. Maybe I'll make a follow-up video on the second channel. Although, like I said, I think people are really sick of me playing around with this thing, so it might be a little bit of time before you see this thing again. As I said, this was an amazing learning experience for me, and I hope people got something out of this entire series, especially on doing troubleshooting with logic analyzers. But as is the case so often in the basement, I just never know what's going to get me stuck, and I hate leaving things broken. I could have just given up on this thing and let it not work ever again, just sit in a box, but I'm glad this thing is now better than ever and working 100%. So if you enjoyed this whole series or just this video, thumbs up would be appreciated, but otherwise you know what to do. Huge thanks to my supporters, huge thanks to my subscribers. If you haven't already subscribed, I would really appreciate it if you just hit that button. I mean, I know it seems funny to hear everyone ask about it, but it makes a huge difference to creators like me. And unfortunately, what can happen sometimes is if YouTube decides one of my videos is not that interesting, it won't even suggest it to people. So if you regularly watch my videos and you're not a subscriber, there's a good chance you might not even see my videos recommended to you at all. And yeah, last few videos on my channel have really kind of suffered that way. And it hurts because I put a lot of time and effort into these videos and I think my viewers would like to watch it. But when people don't watch it and YouTube stops suggesting it, yeah, it's sort of stings a little bit. But anyways, I won't dwell too much on that. That's going to be that. So stay healthy, stay safe. I'll see you next time. Bye.